everyone. This time we go through the formulas of logarithm. I have around like 7, how many? Okay, 9 or 10 formulas for logarithm. Logarithm, to me, for algebra, it's kind of a little hard for logarithm. Especially when you go to derivative and integration, because for mathematics everything they can mingle together. So when everything they can mingle together, and you will have problem. Why? Because every basic things you need to be very familiar, like logarithm, the formulas, like formulas of exponential, right? The formulas of other like derivative, the formula of integration. Those kind of basic things you need to really master, understand. If you know any of this part you are not really master, master is understand, then you have a problem. So right now let's go to logarithm formula. Okay, so log formula, the first one we discussed about the summation. Okay, the summation of the x and y here is the, yes, here is exactly x and y. Okay, so the production of the two items equals to, for logarithm, is equal to their plus together. So we can think about that. Give an example. Log 2 to the 4. Most simple example, we can write in as 4 can write in as 2 times what? 2, right? So we can write in as log 2 to the 2 plus log 2 to the 2. So this is what? 1. This is 1, so it's 2. If we just solve this together, log 2 base 2 to the 4 is 2, right? So this proves that if the production of two items for logarithm, they can be changed to the plus, but the condition is based on they have to have the same base. The second thing, okay, from below 2 to 3, I'm used the natural logarithm y. I cannot explain you why, but I can ask you why not, right? Because it just means that, for me, it just means natural logarithm is just a special case of a logarithm. So there's no difference. Well, I write in this way, just I want to writing a little less. Okay, but for the function, they are same. So this is a division, right? Division, logarithm is equal to their what? Their minus, right? So same, we do the same kind of if this is x is 4, y is 2, so it's logarithm 2, right? If this equals to what? Log 4 minus natural log 2. It's exactly. Okay. So let's see the next formula is a logarithm. This is regarding the exponential function. So the exponential function, we just move the what? This is an exponential function, but it is based on a logarithm. So the result is move the exponential to the front, and then logarithm of the base. That's not a base, logarithm of the x. Okay. So give example. If this is log 2 base over 4, and this is a square. It's the same thing as 2. Move 2 in front. So it's log 2 to the 4. Also, we know 2 to the 4 is 2 times 2 is 4, right? Look at here. If just we don't move, so think about log 2 to the 4 square is 16. 16 is what? 2 to the 4th power, so it's 4. Same, right? Next one is just the reverse. If the base is A and the item is B, I can change the B to the item A, B from item, change the base, and A from the base to item, but they have to be over 1. Let's just prove by, provide by what? Well, what? Just by example, okay? Let's look at here. If 2 to the 4, if is equals to log what? 4 to the 2. Is that right? 2 to the 4 we know is 2, right? How about this one? So this one is 1 over what? Log what? 4, base 4. This is what? This is the 4, 1/2. Am I right? 1/2 is square, right? So since we already know the exponential, they can move in front, right? So this is like what? 1 over what? 1 over 2. Log 4 to 4 is 1, right? So it's equals to 2. Same, right? Okay. This one is change the base. Logarithm, the base switching rule. Base switching rule. So if you want to change the base, that's okay. But you have to make a division of a new base and then to the terms, and the original base also to change to the term and with a new base. So let's give example. Still use here. I always use the most simple one. Okay. If log base is 2, x is 8. Okay. So equals to what? We change to what? I want change to the base is 4. Let's see. 4. 4 is that okay? 4 is not okay. Okay, let's just change the base to the square root of 2. Why not, right? So x here is 8. And here is what? Logarithm square root of 2 and over 2. Original here is what? Is 3, right? Let's see if this one, after we change the base, is the same. So log square root of 2, we can make it, this one was square root of what? 4, am I right? No. Square root of 4, square root of 4 is what? Square root of 4 is, square root of 4 is like square root of square times square root of square. So it's like 4, but here is 8, so it's not. So it's 5. Or 6. Yeah, 6. Yeah, times another square root. Yeah, so 6. And here, as log square root of 2, and the 2 is a square root of 2 to the second power, right? So of course the first one will be 6. The denominator is 6. Numerator is 6. Denominator is 2. So it's 3. Same, right? So that's right. For this one is the difference is that's A. It's not log n. I have log n of the difference. Here is just log a x. They ask you to do what? Derivative. That's what I'm saying. The derivative is hard if they mix together everything. So the derivative of log a to the x is equal to 1 over x and ln. I just give example. I don't prove anything. Okay. Because you want to prove a derivative, let's take a long time. Log. But anyway, aside from this, there's another things. You cannot change this to the exactly the number, or if it is already number, if it is just a constant, it cannot be derivative. Okay, so this one is I will not do any kind of proof exercises right now. Okay. Okay, this one, this number 7 formula also very hard. This is integration of what? Of a and b, log a and b, logarithm is equal to b item times log a to the b minus 1 divided by natural logarithm to the a. So if you are interested, spend some time to try to prove it. So how do you prove it? You just roll derivative of the right side. If they finally get the left side, then you will win. Okay. See the next one. Logarithm a to the 1 is equal to 0. What's that mean? It means that whatever the base is, if the item there is 1, so the logarithm is 0. Why? Because you just look at the opposite way of the exponential way, right? The logarithm exponential, right? So this is like what? A to the 0 power. Am I right? A to the 0 power, of course, equals to 1. So whatever a it is, unless it's not negative, right? So this to 0 power is 1. That's it. So for this one, related to it's a number 9. Formula 9 is similar to number 7, but difference is the base. Here we already know. Here's unknown is a, right? Here is natural, so it's e. So integration of natural logarithm x dx equals to x times natural log x minus x plus c. So this is the formula. Just remember this. And how to prove this formula, they have to use another formula. This formula we call integration by parts. You can look at here. If this is integration already by parts, one is fx, another is the prime of derivative of gx, it can equals to the original form production fx times gx minus, and then minus what? Minus integral of the first item first item derivative, and the second time just keep the original format and do the integration. They have a lot of the example to approve this how integration of nx equals to this one. So you might easy to find any kind of proof here, but if you want, I can just just show that just compare with this one. Okay, so we think about Ln x is fx. Okay, and since that one, so definitely the gx prime is equal to 1, right? We think about this only Ln x, right? If the gx prime equals to 1, then gx equals to what? X, right? So we can write in as integral ln x dx equals to the original one, right? So x times what? X times ln x, alright? Minus what? Minus this integral, fx prime, fx, this one, right? This one derivative is 1 over x, right? ln x, right? And then gx is x, right? And of course, any derivation we should have what? We should have what? We should have plus c, right? So we already get this one, right? It's already same, right? It's already same. So x ln x logarithm minus this should be 1, and then integration you should be x, right? And then plus c. So easy to prove that. Okay, so I'm thinking about we still have a short time. Let's try to make use of the an integration by part to see if it is can really solve some question or not. Okay, so let me think about an example. In fact, this can be very hard. Okay, let's just think about just give example of if integration what x x minus 1. Okay, just like this way, dx. Okay, let's use the integration by part. So this will be fx and times what? Gx prime, right? So if Gx prime equals to x, then Gx will be equals to what? Am I right? So Gx, so fx equals to what? X minus 1, right? So fx prime equals to what? Equals to 1, right? So since you already know this, we can use the what? Integration by part, right? So x minus 1 dx equals to what? The original fx plus gx, right? So x minus 1 times x, right? Fx, then minus what? Minus what? Minus the first is x, so then we are fx, yeah. So gx prime, so fx prime minus minus, sorry, fx prime is 1, right? And then another one is gx is x squared divided by 2, and then of course dx, right? So then this what? X cubed minus x squared over 2. Then it is what? We know that if they have a constant, we can move out, right? So 2 x squared will be what? Will be x cubed times 3. Am I right? Am I right? Yeah. So it will be what? This is a 6. This is the what? 2. So the common factor of denominator will be 6. So 3x cubed minus 3x squared, then minus x cubed. So it's only like 2x cubed minus 3x squared over 6. This is the final answer. Is this right? Yes, of course it's right, right? Okay. So let's review the formula. There we discuss about a lot of things. So today we studied the total dying logarithm formula, and as well we discussed the integration by part and the use for the logarithm to help us to solve those kind of hard integration issue, right? So thank you very much for joining this session. Okay, bye bye.